nice to meet all of you. I'm Phil Hall. I'm a customer engineer at Looker, and I've been here about 4 years, and I've always had a special place in my heart of trying to tune performance, whether that be on the dashboard and the reporting side or even on the database side. So it was really exciting when I found out that this was going to be a topic for a presentation this year, and I can't wait to get into it with all of you. So what we have planned today is, first off, introduction and agenda. We already covered that. But really trying to figure out, when we say, how do you up-level your Looker performance, what does that actually mean? What does good performance mean to you? Because that's going to be varying a lot from persona to persona. After that, we're going to have a little bit of fun, go into a little bit of a role play exercise where we're going to hit the grocery store and we're all going to go shopping. And then we're going to draw on that to figure out how we can show you how Looker can help kind of up-level that performance, all wrapped into that nice analogy. So without further ado, let's power on. So again, what is good performance? Good performance can mean different things for different people, and maybe depending on what you're trying to do, performance might actually be good for one use case and not good for a different use case. So for example, is this fast enough? You got a little scooter, probably tops out at 30 miles an hour. And the answer might be maybe. Maybe if you have a pre-planned trip and you're trying to go from New York to LA, that probably is not going to be fast enough. But maybe if you have a friend who randomly calls you at 2 in the afternoon and says, hey, let's meet up for happy hour, this could actually be the perfect thing to get you there, because you don't have to worry about parking it. You don't have to worry about going to find it or hailing something on an app. You can just get to where you need to go. And so maybe that is fast enough for those types of scenarios. How about this? Is a sports car fast enough? Sports cars are pretty fast, but you can really only use them in certain scenarios. You got to be at the racetrack. So it's probably fast enough if you actually have the means to have that racetrack and you know how to get to the racetrack, and then you want to be able to drive there. But for other circumstances, that might not even be fast enough for you, and you might not even have the means to get access to that race car. So maybe this is fast enough. Maybe you're just going to be on a jet plane. If we go back to that example before of maybe taking the road trip from New York to LA, that's definitely going to be a lot faster. But again, you need to know you're going to take that trip, and you know that you're going to have to plan for that in advance, buy your ticket, go through security, all of these things in order to be able to get that performance. So these types of things are really critical when we start thinking about how we want to up-level performance, because depending on what your end users are trying to do, it's going to be very different for them what performance could actually mean. For reports that they might want to use every day, that might be like this jet plane where we want really, really fast performance. We just want to get from point A to point B really quickly. But if you have people who are doing a lot of exploratory analysis and profiling of data and information, maybe that little electric scooter is actually going to be enough, because it's going to be agile enough for you so you can start asking all these things without having to maybe prepare in advance to be able to get that level of performance. And when we really look at this, we figure that expectations are typically higher the more common a request is. So if you have 1,000 people all going to the same dashboard and asking the exact same questions of that dashboard, it's probably going to be really important that performance is going to be really high. But if you have someone who asks a question and it's the first time that question's ever been asked, they're on a new frontier. Performance, the expectation for that performance probably isn't going to be as important for that type of user or that type of use case. So this is a really interesting framework, I think, to think about as you start segmenting what your use cases are and who your end users are, and trying to prioritize what we should make fast and what's okay to leave. Because at the end of the day, you could performance tune all year and try to account for every single use case, but you're ultimately limited by the number of people you have and the number of time in a day. So you really want to try to isolate what are the areas that you can really get that performance with the least amount of effort that's going to impact the largest number of users. So what might some of those common personas or users look like? In order to find out, again, take our shopping cart, go to the nearest grocery store, and let's go shopping. So here we have 4 different shoppers. And you could think of these 4 different shoppers as maybe 4 different types of end users or 4 different types of personas that you might want a performance tune for. So starting over at the left, let's start with Tim. Now, Tim doesn't even have a car, and he actually just prefers to get the items that he wants delivered because he doesn't live close to a grocery store, and again, doesn't have that car. The only really way for him to get that data or those groceries is to just have it delivered to him. Meanwhile, if we take a look at Susie, She does go grocery shopping, but she's a very, very busy person. She follows routine. She has structure. She's always going to buy the same things. And she always likes to go shopping after work. We know that about her. She has a busy schedule. That's the one time of day that she can go in and really try to figure out what she wants to buy. Next in line, we have Simran. Now, Simran is generally a pretty general shopper. He has a list. He kind of knows what he needs. He takes a look at his kitchen and figures out, like, oh, I might need eggs. I might need butter. I might need some cereal. But often, he's going to deviate from that plan because inspiration will strike him while he's in the grocery store. He might have started off to go find eggs, but then he realized that he hasn't had Eggs Benedict in a long time, and he wants to find the ingredients to make a holiday sauce so that he can really have the eggs that he knows that he wants. But he's starting with that general list, and then maybe deviates from that to really get creative in the kitchen. The complete opposite side of the spectrum now is Alexandra. She's a very adventurous eater. She's always looking for new things, and she just loves to create experimental recipes. So when she goes to the grocery store, she never knows what she's going to buy. She's jetting out to maybe the ethnic section or maybe the adventurous food sections, and she's just consistently trying to find new pairings for food so that she can really just make whatever she wants and see if there's a cool recipe that she can maybe make repeatable, but she doesn't know what that recipe is going to be in advance. Now, this was really focused on people and how they shop for groceries, but it's not so different to how people try to consume data. So if you think of Tim, you could envision him as a frontline worker. He doesn't use BI tools. He doesn't have reports. He doesn't want to log in to see reports, but data is still very much useful in how he does his job, and he needs to get those insights delivered to him so that he can be effective. Meanwhile, Susie is a business user. Her day-to-day job probably requires consistent viewing of certain dashboards, but at the end of the day, she just needs to see what metrics are important and then ask very simple follow-up questions. Simran, however, is probably more equivalent to a power user. Again, he knows what dashboards he wants, but once he gets access to those dashboards, inspiration strikes, and he might completely pivot and say, okay, I saw that maybe my sales were really high in this particular state, but now I really want to drive into that deeply and figure out what was driving those sales. And he has a whole bunch of follow-up questions that maybe that dashboard didn't answer. So he needs an environment so that he can start getting access to those answers and then achieve performance in that way. And then Alexandra would be equivalent of the data analyst. She's always asking complex questions, profiling data. The questions she's asking are often new, and oftentimes the data that is needed to answer those questions are going to live in a variety of different tables. So when we think about up-leveling the Looker performance, we don't want to just think of it for one of these personas. We want to be able to design a holistic strategy that's going to be able to cater to each of these types of individuals. And before we kind of get too much into the specifics, let's think of a database like a grocery store. So groceries are kind of like data. Those groceries are getting organized into aisles. So you can think of aisles as being rows, and then maybe the shelves in those aisles are like columns. So the groceries data, that data is stored in rows and columns, just like groceries are stored in aisles and shelves. And if you have a really big store and you don't really organize your groceries that well, it's going to take your customers a really long time to find out what they need. That is just the same way as a database. We often see databases, the larger they get, the more disorganized they can be, and the harder it is, and the slower it is for people to actually answer the questions that they have. But we can help take several core principles to accelerate that journey. A few quick concepts that I just want to breeze over before we get really quickly into the examples are the concepts of partitioning, the concepts of indexing or clustering, pre-aggregation, as well as denormalization. So we can think of partitioning as setting up these aisles in the store. So if you know you have like data, maybe it's based on a particular time frame, maybe it's based on a grouping of your customers or ways you want to organize data, you can make sure that all of that data lives in the exact same time. So if maybe you were to partition something by year, all of the data from 2019 would live in one partition for 2019, all the data from 2018 would live in 2018, etc. So when you start searching for data involving that particular date range, it's much faster because you can just go to one aisle to get the answer to what you need, as opposed to trying to search through every aisle to find what you want. Partitioning could be a different term, but for the most part, most databases have the same concept. Something like BigQuery, it's partitioning. In something like Snowflake, partitions are actually created automatically, depending on how you want to organize the data. And something like Redshift, it might be more akin to a distribution key. To the next item of indexes and clustering, you can think of that as how the products are getting actually arranged and organized into the shelves. So if we go back to thinking that maybe the year is how we're organizing the aisles, I have questions from 2019, we can say, hey, maybe within that aisle, I want to organize all of my items on the shelves by color. So if I want something that's red, I can just go to the aisle where I see a bunch of red things, and that's where I can find all my red groceries. The same concept is true for data. Maybe you know that your data is in 2019, so you go to that aisle, and then we're going to sort and organize all of that data based on something else. Maybe that's a customer ID, maybe that's a geography. And then so you can easily get to the place in that aisle that you need to faster when you know that the data is organized in that way. For pre-aggregation, you can kind of think of that as like hot and ready meals. So if you go back to that example with Simran earlier, where he originally just wanted to buy eggs, but then he decided that he wanted to buy Eggs Benedict, we already know all the ingredients for Eggs Benedict, so we can actually package that entire recipe up, make a pre-made meal, and just have that sitting out for somebody. That's what pre-aggregation accomplishes. If we know that there are recipes or questions that people are going to be asking a lot frequently, we can actually just pre-package all of that data up and set it at the front of the store, so people don't even have to go searching down the aisles or looking for items in those aisles. They just go find their meal, and then they're off to the races. So you can think of pre-aggregation as a lot like that. Then we have denormalization. And so for people that are akin to data, often we deal with what we call fact tables and dimension tables. The fact tables being a lot of the numbers and the metrics that we might want to compute, and then the dimension tables being how we describe those things. Oftentimes you would need to join to those dimension tables to answer certain questions. But as databases are getting cheaper and more powerful, we actually can pre-join all of that data together, and that's what we call denormalization. So what you can think of it is maybe if we go back to our college days, it's the exact same concept as when you go by over to the aisle with red Solo cups, you're going to find ping pong balls in a college town because people know that if you're going to buy Solo cups, you're probably playing beer pong, you're probably also going to want some ping pong balls. So you can think of that as denormalization. These are just ways so that when you go into the store, you can find the things you need faster. All of these parallels are true when it comes to data. So as we take these concepts, let's actually dive in and follow those personas on their trip to the grocery store so we can actually figure out how we want to help these people. So you might have remembered from the persona slide earlier, Tim didn't have a car, Tim didn't live close to a grocery store, so he needed to deliver or get his groceries delivered. We can take that same thing to make sure that Tim gets access to the data that he needs through simply scheduling. So in this case, we have our grocery store, we have our aisles, we have our checkout counters, but all that's kind of irrelevant to Tim because Tim's not going to go to the grocery store. He's relying on someone else going to the grocery store and finding all the things that he wants from those aisles and then bringing it straight to his doorstep. So when we think about those performance tuning concepts and those principles that I detailed earlier, when it comes to Tim, it will definitely help make it faster to get that food or those data points delivered to him. But it's not something maybe we got to think really critically about because at the end of the day, we just need to know when Tim wants his food and how frequently he wants his food. And that's when we just need to set up those schedules. And so taking that to the data level, I'm going to dive real quickly into a demo to show you how we can pre-schedule those deliveries for someone like Tim. All right, so we just went from the presentation to a dashboard. Let's think of this dashboard as Tim's regular order. He gets all of these different metrics, and it's always got to be delivered at a particular time to his house. But maybe we know from Tim that there are certain items that if they're ever in stock, we want to make sure that we get those to Tim right away. So there are a lot of different ways that we can do that within Looker. We could actually come to any of these little tiles and actually set up an alert to say, hey, if this metric goes above or below this particular threshold or changes, let's send that to Tim. Just like it might be, hey, there's this really specialty item, it's in stock, let's get that over to him. And then we also have the ability to schedule the entire order. So maybe we just know that Tim's everyday order is always going to be daily, or maybe it's every week on Monday at 8 in the morning. So we can just go ahead and schedule that to Tim. But we can take the exact same concept actually as, well, what if all of my items are immediately in stock? Or maybe we actually want something on an auto subscribe so that if he runs out of food because he's got a smart refrigerator, we just want to, by default, send him that order. That concept exists within Looker as well, where we can actually listen to particular patterns like I'm all out of food, and then every time we notice that pattern, we're just going to go ahead and schedule that delivery to him. So a lot of different ways that we can speed up that process to make sure that Tim gets the data that he needs. But Tim is just one person. You might be scheduling data to thousands of people like Tim. So it's very important to make sure that we aren't trying to schedule all these deliveries when we don't have enough delivery people to do that scheduling. Luckily, within Looker, we have something called system activity, which you can kind of think of as Looker on Looker data, so that we can really analyze when all of these deliveries are going out. So even though that we pretty consistently deliver things equally across every day of the week, we might notice here that around 1 p.m. is when a lot of these deliveries are going out. We are going to want to make sure that we monitor this so that if we do have a bunch of deliveries going out and maybe not enough delivery people to actually drop that food off, that we can maybe talk to some of those users and say, hey, Tim, are you actually okay getting your food an hour earlier or an hour later? And so those are tools that you're going to want to be able to better administer and monitor this as you're delivering data to your different personas. So while for Tim, all we had to do was schedule those deliveries or schedule the delivery of that data, whether it be food or reports, Susie actually does go to the grocery store. But if you remember what we discussed when we talked about Susie was she has a routine. We know when she goes to the grocery store, and we know the types of things she's always buys. She's, again, very process-oriented. Thinking this to the data world, she has her favorite dashboards. There's probably a couple filters she commonly interacts with, and she might use the exact same drill paths over and over again because she sees that sales are higher in one area, and then she wants to quickly follow up why, and then she's back to the main dashboard. So with Susie, again, when we think back to this grocery analogy, we don't need to have Susie go to the grocery store and find what she wants to buy herself. Because we know that she's going to come to the grocery store after work, we can maybe have an in-store shopper go to those aisles, pick out the items we know Susie's going to buy, and have those available right at the curb. So as soon as Susie drives up, she can grab her items and then she can go on home. So again, those concepts before of how we organize the data, maybe not as important for someone like Susie. So in the Looker world, we can think of this as caching, which essentially means of, do we know what Susie's going to ask? And has she asked that question before? If so, we can keep that order or that recipe, if you will, in cache. So the next time Susie comes to the grocery store, we can just give her those results, just like curbside pickup. And so we can use this approach within Looker to make sure that as soon as Susie logs in and she goes to the dashboards that we know she's going to see, those are going to load instantly because we already had someone pre-prepare all the necessary ingredients or data that's going to surface to those dashboards. So with that being said, let's take a dive into Looker to show how we can actually configure that caching and make that dynamic so that Susie gets access to those dashboards and that performance is instantaneous when she logs in to interact with them. So now when we think about Susie, we know that she likes to ask the same types of questions in a very structured manner. Maybe one of those questions are just, what are my top 5 brands? And so as you can see here, I've already actually constructed Looker's exploration environment to ask that question. In this case, I selected brand, total sale price, and limited that to the top 5. And you'll notice that this query is running against the database because this is the first time anybody's asked this question. So when we run this, this is actually going to go back to the database. You'll see it took 1.2 seconds, and here's the answer. But if I click run again, this is actually going to pull from cache. And so we can take this concept to say, hey, regardless of where the food is organized in the aisles, where that data lives, we know that Susie's going to ask these questions. So we can actually make sure that we can pre-cache a lot of these things in advance. So let's actually go back to the dashboard that we saw as Tim's order. Let's say this is Susie's type of order as well. We actually then have the ability to pre-schedule this dashboard out, again, at a particular time of day, or using that concept of a trigger or looking for a pattern to make sure that before Susie comes to the grocery store, we've already pre-assembled all the things that we know she's going to buy, so that as soon as she gets there, her orders are there and she can leave, just like that dashboard is going to be able to load instantaneously. And if we had any kind of questions to figure out, all right, well, what types of groceries do we need to make sure we provide for Susie, that same concept of system activity can be beneficial here as well, where maybe we want to filter on a particular user, see the actual queries and questions they're most commonly running, and we can use that to inform that scheduler so that we can go and make sure, based on the time of day and the types of questions that are asking, that we already actually pre-compute and get those data result sets for the questions that they're looking to run. So when it comes to Simron, this now is a situation where the organization of this data becomes more important, and it presents itself where maybe we can start pre-aggregating the data. So again, Simron was the person who had that grocery list. He knew he wanted to buy eggs, but then he got to the grocery store, inspiration struck, and he wanted to buy some Eggs Benedict. If we know that maybe Simron has similar patterns, and he often, we can start to delve into why or how he gets inspired, we can either A, organize the data so that a lot of things in those aisles, all the ingredients he needs for Eggs Benedict are in the same place, so he doesn't have to go searching in multiple aisles. Or we can take that concept of that hot and ready meal and pre-prepare those meals for him and have those right at the checkout counter so that as he gets in, he knew he has eggs, the first thing he sees is Eggs Benedict, and he's like, great, I got what I needed, and then he can leave without having to do any more searching in the grocery store. The same thing we can do within Looker. And we can either do that through organizing the data. So if we go back to that idea of partitions, maybe we actually want to reorganize the data so that everything is stored by maybe meal of the day, breakfast, lunch, dinner. And then within that, we want to organize by dairy or different types of meals. We can do the same thing when it comes to data, or we can reorganize it to be very prescriptive for people like Simron so that they scan through the least amount of data to get answers to their questions. We can also use a concept within Looker called derived tables and persist those back to the underlying database, taking those same examples of kind of organization and have those ready for Simron so that if there's a meal that we already thought or we prepared for somebody else, he doesn't have to go try to find those ingredients. He can actually hit an area where all of those have been pre-prepared for him, and then he's off to the races. So with that said, let's take another dive into Looker to showcase how we can build these derived tables so that we can have better performance as Simron goes to the grocery store, or as Simron begins to maybe start with a particular dashboard, but then ask a lot of follow-up questions that we can maybe start to predict in advance. So now with Simron, we want to use Looker to figure out how we can make that pre-built meal. And so what we can use within Looker is essentially taking all of the relationships between the data or the relationships between all these different groceries in a recipe, and we can actually figure out a way to pre-build some of these analyses for Simron in advance. And so maybe this is something where we want to take something like a user, and we just want to be able to describe that user that pre-joins a lot of these different tables. So maybe we want to take an ID of the user, the name of that user, and then just a bunch of different things that describe them, like the average days it takes to serve them, the sale price, the profit, etc. We can go ahead and run that query. The logic to actually service this might actually be relatively complex, but we have the ability within Looker to again say, hey, we know that Simron likes this type of a recipe. We want to make sure we have it pre-assembled for him when he comes into the store. I can just come over and click this gear icon, get the LookML for how we actually want to construct that derived table concept that I was referring to earlier, copy and paste that right into our model. And so just as a quick example of what that looks like, could be something like this. So in this case, we're specifying here that we're deriving that table with all this different logic that's just using those different definitions, which you can just think of as like ingredients or products in that recipe. And we can actually then choose to organize that in the aisle as well. So when we remember those concepts of partitions, clustering, and indexes, we can use that same type of thing when we're building those pre-made meals for Simron. So right now, we're just saying that, hey, we want to build these meals at this type of day and make sure they're on the shelves. But again, we can use that concept of cluster keys or that concept of partition keys or that concept of indices to really make sure that as they're searching for that particular pre-made meal, if there's different types of pre-made meals that are in that same kind of variety, he gets exactly to where he needs as fast as possible. Now, Alexandra is the tough one because, again, she is that adventurous shopper. She's always trying to think of new recipes. So she's that data analyst All of her questions are generally pretty new, and she's asking really hard and complex questions. So a lot of the times, the way that we actually organize the data can only go so far. Because if maybe we organized all of our aisles in a very logical way, maybe by type of food, but Alexandra wants to maybe combine pickles with something really weird like chocolate because she got inspired or saw something that wanted to combine those two very different flavor profiles, those might live in two different sides of the grocery store. So it's really hard to try to predict the types of random questions that Alexandra might try to ask when she's formulating these new recipes, just like it's going to be really hard to potentially predict all the different ways a data analyst might try to ask questions of the data. But that doesn't mean we can't try. And so what we can do is really try to piece together maybe again some of these common questions. Maybe as we see Alexandra coming into the grocery store frequently, we can maybe find patterns in the way that she goes to the grocery store, and we can try to prepare to maybe create, again, denormalization or using pre-aggregation to find maybe some ways that we can give her better performance based on that past behavior. And the really cool thing when it comes to Looker is we can also have those experiences being completely dynamic. So think of it as Alexandra goes to the grocery store and we know that she wants to combine Indian cuisine with Mexican cuisine. We can actually dynamically point her to a brand new grocery store that only has those ingredients. The next day, she wants to combine maybe breakfast foods with chips and salsa. She has another store already pre-built for her, and that store is going to change as she walks up to it. In Looker, this is a concept that we call aggregate awareness. And so we can take all of those principles that we discussed before, like partitioning, pre-aggregation, and denormalization, but we can define all the different ways that those are done in advance, and then Looker will actually dynamically query each of those different aggregates depending on what the end user is actually trying to do. And so this is a little bit of a difficult concept to wrap our heads around just talking through it. So let's hop into the demo and actually show how this can be done and how that actually is going to allow people like Alexandra to potentially get much better performance when they use Looker. Now, as I mentioned before with Alexandra, it becomes a lot trickier to try to think of what are the most performant ways to make sure that she can answer all of her questions, because a lot of the times we just won't know what questions she's trying to ask. But what we can do is to try to preempt as many of these questions as we think are potentially possible, and we can actually build those into the exploration environment within Looker. So for those of you who are maybe unfamiliar with this screen, this is LookML. An exploration environment is the creation of that environment where you can point and click and create dashboards and ask net new questions. And that's also where you can describe how all of these different tables are actually joined together. And again, Looker's only going to do those joins when necessary. But we can use this concept of aggregate awareness in the form of these aggregate tables. And these aggregate tables can use all of the same performance tuning concepts that we described before, whether that be, again, something like a partition or a cluster. And we can even include fields that are spanning multiple tables so that we can actually denormalize, pre-aggregate, and make sure that we actually make those tables and those data sets small and easy to find. So in this case, I've actually just created two aggregate tables, one for the state and year. You can see that I'm bringing in the year and the state as different dimensions of this query. So you can think of these as maybe the categories of the groceries that Alexandra is trying to find. And then the metric being total sale price. So how do we actually want to bundle up everything and aggregate these different metrics? And then I have city month, which is the very similar concept, but we're using the month and the city, and we're keeping that total sale price intact. But this exploration environment is actually based off of our order items table that actually includes every single order item and every single transaction that took place. And so what this allows us to do is predefine and try to predict what might make some of Alexandra's questions go a lot faster. But if not, we always have the ability to fall back to just the default grocery store, and then she can find whatever she needs. Might take a little bit longer, but that's sometimes the price you pay for flexibility. So what that looks like, if I come back to our exploration environment, is if I want to look at something like total sales, this is actually going to now use that aggregate table. You'll notice here it says we're looking at our state year. This is what we defined here. And that's because everything that we needed to answer this particular question was available in this aggregation. So when we go ahead and run that query, That's going to run really fast, and it's going to actually use that table that we're building because that's going to be pre-aggregated as well as denormalized so that we can have a really fast question when Alexandra asks that type of a thing. Meanwhile, if she wants to go in and also populate that, let's say by state, she wants to understand sales by state, we're still actually going to leverage that exact same table of demo state year because, again, everything that we needed already existed in that aggregate that we already built up. We're going to run the query, and it's actually going to point dynamically to that different aggregation that we created. But let's say Alexandra then wants to drill down and figure out what cities led to those sales in that state. I can go ahead and click on city, and now Looker is actually smart enough, which you'll notice here in the SQL, to point to that demo city month. So again, that's what we defined here. So we weren't able to use this because city did not exist at this level, but because it existed in this aggregate, we're going to go ahead and point to that. That query is going to be a lot faster. And then maybe we only have to worry about going back to the raw data if she asks even more follow-up questions like something like zip code. And in this case here, you'll see that we're actually just hitting that raw order items table because zip code did not exist in either of those aggregates. And the really great thing about Looker is you don't have to always think about what those aggregations need to be. You can again see what type of content is most popular. And so if we go back to something like this dashboard, we can actually go ahead and get the LookML for all of those different aggregate tables based on this report. So if we see that Alexandra is going to this report a lot and asking a lot of follow-up questions, we can actually just go ahead and get the aggregate table LookML for what we need to run this particular dashboard. And then we can just plug that right into the model. And now whenever Alexandra interacts with this report, things are going to be much faster because we can do a lot of that pointing and a lot of that querying dynamically to always use the fastest object available. And so that wraps it up for all the demos. We successfully took 4 different personas shopping. We figured out how their shopping journeys translate into the analytics world and how we can use approaches within Looker to make their experience more performant and better. So I hope you enjoyed it. I know I did. If I can just leave you all with one parting word of wisdom, again, you can take these concepts and you can performance tune literally forever. So I really just want to emphasize that you find out who those key shoppers are or who those key personas are and just try to make the most time-effective and cost-effective ways to cater those performant experiences to your most important people. Because at the end of the day, you don't want to spend all of your time just making things fast. We really just want to drive that business impact. And so that's just making things fast for people who are going to be able to take that data and take those insights and really have a better impact on the organization as a whole. So again, I'm Phil Hall. Hope you enjoyed the session. Please make sure to tune in to all the other amazing sessions we have at Join at Home. We got a lot of practice last year when we had to do this, so this year should be even better. You don't want to miss out. Have a great day, everyone.